Hello class. Today what we're going to do is introduce three-dimensional figures. We've been talking a lot about two-dimensional figures. Now we're getting into three dimensions. And so that brings us to polyhedrons. All right. This is a polyhedron. More than one of them is called polyhedra. All right. So a polyhedron is a figure that has flat faces. Notice these over here are not polyhedra. Right, because they all have curved sides, curved faces, kind of surfaces. All right. One thing to mention, okay, the corners here, these are called the vertices, just like they are in a two-dimensional figure. All right. However, three-dimensional figures do not have sides. All right. This right here is an edge. All right. These are edges. The flat surfaces are called faces, not sides. Two-dimensional figures have sides. Three-dimensional figures have faces and edges. And that way we can specify what exactly we're talking about. When you talk about the side of the shape, or you're talking about the edge, you're talking about the face, what are you talking about? So it's just faces and edges, no sides in a three-dimensional figure. All right. Polyhedra only have flat surfaces. Cones, cylinders, spheres have curved surfaces, and so those are not polyhedra. These are prisms and pyramids, pretty much it. So what we're going to do, tell whether each solid is a polyhedron. If it is, we want to name the polyhedron. All right? And there's two basic names for polyhedrons. You have prisms, you have pyramids. And then you name them each by their base, which you should have learned back in junior high when you started looking at these things. So number A here, this has all flat surfaces, so it has faces and bases. So this is a polyhedron. And the bases, it has two bases that are parallel to each other and congruent. So this is a prism. And those bases are rectangles, so we call it a rectangular prism. The difference between a prism and a pyramid is that a prism has two bases that are parallel to each other. Whereas a pyramid, number B, only has one base. One base and one apex. That's right here, this vertex where all of these other faces come together. That's called the apex, which is opposite the base. Prisms are also named by their base. So the base of this prism, this pyramid is a hexagon, so this is a hexagonal pyramid. All right. Question C, it has curves, not a polyhedron. All right. This is a cone. It has a circular base and one curved surface with an apex. Cone, not a polyhedron. I want you to answer those same questions for these three here. Is it a polyhedron? If so, what's its name? Alright, let's see how you did. Number one, yes, it is a polyhedron. All the faces are flat. And it is a pyramid because it has one point, one base, one apex right there. And the base is a square because it's got the little tick marks marking them congruent and a right angle there, so square pyramid. This has a curved surface, so it is not a polyhedron. It does have a base, two bases, so not a polyhedron. Over here, we have two bases, rectangular faces, two bases. The base is shaped like a triangle, so it has a triangular base. This is a prism because it has two of them, so it's a triangular prism. All right? Easy stuff. You all probably already knew that. Now, what we're going to talk about here are the cross sections of three-dimensional figures. The cross section is what is formed when you have a plane that cuts through a three-dimensional figure. And as you see, they can do all kinds of shapes. And let me pull this up here. You can see it a little bit better. So here I have a square pyramid, and you have the cross section. So you can obviously see, of course, a square, a pyramid. You cut it with a plane, you're going to get a triangle, right? And we can move that around, and it's a triangle. But what if I turn it? Is my cross section still a triangle? Nope. That is a pentagon. Now I've got a kite. Right? I can move it around, and I get all kinds of different shapes. There's its square. Right? So all kinds of different things depending on the angle of this cross section. Right? Get some really fun looking stuff right there. What about for a prism? What kind of shapes can we get with a prism? Well, that's interesting. That is a hexagon. If I move it, now I've got a pentagon out of it. And what kind of prism is this? This is a pentagonal prism. Let's move that down. There. Now we've got a rectangular prism. Cube looks like. And I still get a hexagon. 1, 2, 3, 4, 5, 6 sides out of a prism, out of a cube. All right, move that around. Now I've got 4 sides. Now I've got a triangle, just cutting off the corner there. So you can do a lot of things with it. You get a lot of different things. Here's a cylinder. Right. Obviously, we have the circle right there. But if we rotate it, we get these other shapes. Let's see, move down. You get a half circle. You get other arcs of circles. Things don't work. We can turn it a little bit. Now I've got, let's see, move it right there. Now I've got an oval. Well, I would have an oval if my cone was longer, cylinder was longer. Cone, get lots of different shapes. I can get a circle. Move it all the way up. I get a point. If I can move it all the way on this one. Let's see, move it like so. Triangle. Well, no, that ain't a triangle. Now it's a triangle. Now it's some kind of weird thing right there. That's actually a parabola. Not that. Parabola. So all kinds of shapes you can get that. Those are cross sections. There we go. So here we have a hexagonal prism being cut by a plane, and we get a hexagon. Always? No, not always. Here we have a triangular pyramid cut by a plane, and we get a triangle. Here we have a cylinder cut by a plane. It's parallel to the bases, and that was a triangle. See, is a rectangle. All right, you can see it right there. A little hard to see from the angle there. D gives us a circle. Does it have to? No, but it's parallel to the base, so it gives us a circle on a cone. If it was at an angle, it would be an oval. Here we have a sphere. Sphere is nice because there's only one thing you can get out of a sphere when you cut it through with the cross section, and that's a circle. Every time a sphere, all you can get is a circle. Doesn't matter how you cut it. And here we have a cube, looks like. Rectangular prism anyways. And this is not giving us a square, is it? Because it's at an angle. What we're getting here is a trapezoid, because this side is longer than this side. Those two are not. Those two are parallel. So we have a trapezoid. Alright. What I want you to do is look at these three here. Tell me what shape the cross section is. Alright, let's see what you got. Number 4, pentagon. Right there on the pentagonal prism. Here we have a hexagonal pyramid, and that, looking right there, is a hexagon. Cuts it straight with the parallel with the base. Here we have an octagonal prism, but we don't get an octagon when they cut it, do they? No, they cut it going sideways, and so we get a rectangle. Alright, last thing we're going to talk about. We are going to talk about what happens if you have a solid that you produce by rotating a two-dimensional figure around an axis. Alright, so I have a square right here. Ignore the pencil, just look at the green square. Rectangle. What kind of shape do you get if you spin that rectangle around the pencil? Right? Well, you get another rectangle, right? No, not if you look at it like this, you don't. Now, you can quite clearly see that is not a rectangle. That is a cylinder, isn't it? Yeah, it's a cylinder when it rotates around there. So when it spins all the way around, you get a cylinder. We can do a triangle as well. Let me put that down there. A triangle. It just gives me a bigger triangle. No, it's not a triangle, that's a cone. Alright, so you can see how when you spin it around, you get a cone. Alright. So, three-dimensional figures can be formed by spinning a two-dimensional figure around an axis, by rotating it around there. Alright. Now notice here on the cylinder, the height of the cylinder is the same as the length of the rectangle. The radius of the cylinder is the same as the height of the rectangle. Alright. Over here, when we spin it around as a cone, the height of the cone, the altitude, is the same as this side here, the side that we're spinning it around. And the base, the radius of the base, is the same as the base of the triangle. All right? So what I want you to do is pause the video real quick and tell me what kind of shapes you would get by rotating these figures around the axis that has this line right here with the arrows on it. And then describe it. Tell me what the dimensions would be. All right? So pause the video, then come back and check your answers. Alright, let's see how you did. Number 7, we're going to take this triangle, we're going to spin it around right here, and we get a cone. The height of the cone is right here, from the base to the apex. So that is the 4 units there. The radius of the cone is the height of this triangle. Alright. Number 8, we're going to spin it around this axis, this vertical axis. So it's going to spin around this way. And that's going to give us a cylinder. The height of the cylinder is the height of the rectangle along the axis, that length right there. And the radius of the cylinder is the base on your rectangle. All right, what about number 9? Spin that around. What does that give you? Gives you a sphere. All right, and if you don't see that, I've got one of those too. All right, okay. Got my little half circle. A sphere. All the way around, no matter how you hold it, it's a sphere. Alright. So, you see, it's sphere, it's got a radius of 7, same as the radius of the half circle. Notice, all of these, when we rotate a two-dimensional object around an axis, none of these are polygons. You're either going to end up with a sphere, a cylinder, or a cone. They are all going to have curved surfaces because you can't spin around in a circle and have corners, because circles don't have corners. Right? So it'll always have a curved surface. There will never be polyhedrons. Sorry, I said polygons. I meant polyhedrons. They'll never have polygonal bases. They'll have circular bases, every one of them. All right? So that is introduction to polygons. Polyhedrons, three-dimensional figures. Remember, polyhedrons have flat surfaces, always and only flat surfaces. Pyramids have one flat base, and all the other surfaces, all the other faces come up to an apex. Prisms have two flat faces, two bases that are parallel to each other, and they are congruent to each other. All right? I hope that helps, and I will see you next time.